In this project, you'll use a button to affect whether an LED light is on or off, as well as the serial monitor to see inside this program and see how the computer interprets those signals. Within the void setup function, use a pin mode function with the arguments 6 and input pull-up to set up your button on port 6. Remember that this underscore between the words input and pull-up is made by holding down Shift and pressing the dash key, which is next to the 0 on my keyboard. Next, use a pin mode function with the arguments to and output to set up an LED light on port 2. Next, you'll use the serial.begin function to set up the serial monitor that's built into your code editor with an argument of 9600. Inside the void loop, we have a function that looks exactly like the function from the program prior to this one. It's a digital write function with the arguments 2 for the port that we want to digital write, and the argument digital read 6 to determine whether we're digital writing that port high or low. The digital read function has one argument, and it's the port that we're taking the reading from. In this case, we have a button plugged into port 6, so that's going to send either a high or low signal into the code. We're going to use that high or low signal in place of the word high or low and use the signal to determine whether the digital write of 2 is on or off. The next line of code here is a serial.print function. In the past, we've used serial.println, but this is just serial.print. And what that means is that this message is going to show on the serial monitor, but it's not going to create a new line before the next message prints. We want it this way because we're using this line to print out the text for a status. We're saying button status as a text message, and then we're using the serial.println function to show the digital reading of port 6. So we want this to say button status : space, and then show us the number that corresponds to digital read of port 6. Because this is serial.println, a line break will be created after the digital read shows, which makes room for our next message on the serial monitor. Serial.print the words LED status, a colon, and a space, and then serial.print the digital reading from port 2, which is the LED light. There's a delay of 500 milliseconds, which is half a second, with the LED status and button status showing on the serial monitor before the code reaches the end of the void loop, jumps back up to the top of the void loop, and turns on or off the LED based on the reading from port 6. Keep in mind that this delay of 500 milliseconds makes the data a lot easier to see, but is also going to make your button slightly less responsive. So you may need to hold the button for a second for it to actually change the LED status and button status on the serial monitor. When we upload this code to MakerBoard, and then press the monitor button and scroll down, you can see that we start printing the button status and the LED status. Both of them are 1 right now, which means the button is unpressed and the LED is on. When I press the button, you can see that the statuses go to 0, and when I release, they go back up to 1. The statuses are always in sync, which makes sense because we're using the return of the digital read function as the status of the LED light. So they're always going to match each other. This is a great way to use the serial monitor to see inside the code and understand how the computer is interpreting those high and low arguments as actually ones and zeros.